So this is an example of a one-sample t-test. A political scientist wondered whether Americans belonging to a particular political party were less likely than Americans in general to agree with the statement, "Nobody is above the law." To pilot her study, she asked 9 people aligned with that particular party to rate their agreement with that statement on a 10-point scale. She knew that Americans in general had very high levels of agreement, mu equals 9.02, sigma unknown. Scores from the 10 Americans belonging to the party are below. Use the 0.05 significance level to test her hypothesis. So our first step is to parse the problem, and we know that we are comparing people from a particular political party with people in general. We know that what we're measuring is agreement with law statement, with the law statement. And we know that we're looking for a one-tailed low because it says they would be less likely. One-tailed low. Our research hypothesis is that population 1 will have lower agreement scores than population 2. And we could also write that HA for alternate hypothesis. Mu 1 will be lower than mu 2. And our null hypothesis is just exactly the same, so I'm going to copy it, but we're going to add the word not right here before have, will not have lower scores. And in the shorthand version way, I can simply write equal as the easiest way to do that. Next, we need to pull out the information about the sample that's given in the problem. So I can see that n equals 9, and I know that degrees of freedom then equals 8. The mean for this sample is not given, so I'm going to calculate it by typing my equal sign. You can follow along in the formula bar. And I know that I can just use a shortcut here and type average. And I can just select these cells and hit enter. And it says that the average is this 8.55556. I'm glad we're not doing this by hand. So let's go ahead and get our sum of squares. Our sum of squares is calculated with the formula x minus m and then x minus m squared. So let's write this in. I'm going to take this box out for now. We know what we need to sketch. I'll put the formulas down here instead. So SS equals the sum of all the deviations, which is just x minus m squared. So let's go ahead and get the deviations. So I'm going to click on this 8, which is the x. So I have equals C9 minus the mean, which is this big long one. And I want to stabilize it and tell Excel, don't move on, always subtract the number right in this row. Don't go on as I go on. So I'm going to put a $sign right in there before the number of the row, so before the 12. And now when I copy my formula, I'm clicking in the cell, I'm going to hit Control C and paste down. Now, when I paste Control V, it should move along to that cell. And let's take a look and make sure it did that. And it looks like it did the correct thing. It did this 8 minus that m. So we have good calculations there. We can now go ahead and square them. So I'll type my equal sign. I'll click in the first deviation cell, use the square symbol using the caret and the 2. And now I have the squared deviation. I'll copy and paste. Let's double check, make sure it's correct. That looks right. That is the square for this cell. All I have to do to get my sum of squares is sum those. So I'm going to equal sum, and I'm going to select these cells to sum the squared deviations and hit enter. Next, we go on and we figure out the comparison distribution. So first off, the center is going to be equal to mu, which is given in the problem. So let's look in the problem, and it says that it's 9.02. So I can type that in this cell. That will help us later on. And I can write that here, mu equals 9.02. The shape of this distribution is going to be the t-distribution for degrees of freedom equals 8. The spread is going to be SM, and the standard deviation for the distribution of means SM is just equal to the square root of the estimated variance for the distribution of means. All right, and where do we get that from? We get the estimated variance for the distribution of means by taking the estimated variance and dividing by n. Where do we get the estimated variance from? We just take the sum of squares and divide by degrees of freedom. And so that's it. These are the formulas we're going to use. We're going to start at the bottom and figure out our estimated variance right here. Estimated variance is sum of squares divided by degrees of freedom equals, so I'm going to go up here and hit on the sum of squares and divide by degrees of freedom. Next, we have to get the variance for the distribution of means. So we've done this. I'll check it. Now we're going to do this. We're going to take our EVAR and divide by n equals EVAR divided by, and now I'll make sure to carefully click in the n. We get that 0.08642. So now we've done this. Now we have to do this. We have to take the square root of EVARM. Let me put the E in here. And we're going to go equals square root of EVARM. And so now we have all the information we need. We can see that the standard deviation for the distribution of means, the SM equals 0.2940. 0.2940. All right. Next, we find our cutoff point. Our cutoff point requires us to know alpha equals 0.05, tails, one-tailed low, and degrees of freedom, which equals 8. We can now pull up our calculator. That is our cut point calculator, which is right here. And we can look up. We have the 0.05 there already. We have to change the degrees of freedom to 8 and calculate. And we find that we get a 1.86. We know that we have to go in the opposite direction. We need a negative 1.86 because we have a one-tailed low test. So let's put our cutoff point. T alpha equals negative 1.86. And we can draw this distribution. I'll draw it right here. There we go. We'll put in our 0, 1, 2, 3, -1, -2, -3. And we need to indicate the put point of minus 1.86, which will be between the 1 and the 2 and closer to the 2. We'll write T alpha equals negative 1.86. And let me get our draw menu active here if we can. So we're going to shade in the fail region. This is where we have to find, this is where our score has to be if we can reject HO. And of course, here is our fail region. We next calculate our t-score. That is our last calculation. And our t-score, I'll put the formula here. Oh no, I think I'll put it in red. T equals m minus mu divided by standard deviation for the distribution of means. So we can calculate this formula right here. equals, and in parentheses, remembering, whoops, I didn't intend to put it there. Let's put it right here where our calculations are, equals, in parentheses, M, no, I'm just clicking in that cell, minus mu divided by our calculation for SM. And we find we have a t-score of t equals minus 1.58. We can plot that right here. And it is not far enough over to the extreme to fall in the reject region. So we'll kind of squeeze it in here, minus 1.58. And so because it's in the fail region, our decision has to be to fail to reject HO, and we can write out our conclusion. What is our problem here? It is Americans belonging to a particular political party do not have, I'm going to jump to the next line, significantly lower agreement scores to the statement, nobody, and I'm going to jump again to the next line, is above the law, than Americans in general. I write the statistic, the T is the statistics. Next to it, I can put in parentheses if I don't want to use subtense, the degree of freedom, which is 8, equals negative 1.58. And I can just write NS for not significant. That's the end of the problem.